All right, law of cosines. We talked law of sines the past 2 days. Basically, what you can do and what you want to do is up to you. Okay, you really have two options whenever you're. In some cases, you have no choice, but you're going to have to at least use law of cosines at least once. Okay, but once you find one of, say, like a missing side or a missing angle, okay, you can go back to law of sines if you would like to. That's not a must. You don't have to, but you can. Okay, you will today, what you will have to do, at least the first step in everything that you do, you will have to use law of cosines. Okay? Law of cosines, you're going to use it whenever only thing you have are all sides. And then whenever you only have two sides and an angle. The problem with this is why you have to use law of cosines when you have two sides and an angle is because you don't have the opposite angle or the opposite side of the actual angle that you have. Okay, so that's why you have to use law of cosines. Okay, yesterday we used, or last 2 days we used law of sines, and we still had, say, two angles and a side, but two of those, like the angle and the sides, actually matched up as far as their relationship with one another. Okay, whenever you have law of cosines, any of these, if you are solving for, like in the one case of having all sides, what I would suggest to you, or what I would tell you to do, is rewrite your formula as, in this case, it would be a squared minus b squared minus c squared divided by negative 2bc. It would be equal to cosine of a. It's going to do the same thing, and I'll pull it out here. If you are missing a angle B, but instead it'll be b squared minus a squared minus c squared all over negative 2ac to find cosine of angle B. Then lastly, if you have, you can do the same thing with angle C, where you take c squared minus a squared minus b squared divided by negative 2ab. I will have some students that will say, especially if they are missing, if they only have three sides. Okay, so the three that have the arrows, that's whenever, if you have three sides, that's what you're going to want to do, because you're going to have to find an angle somehow, some way. All right. So because it's not right triangle trig, you can't just do sine over cosine, or excuse me, opposite over adjacent, or adjacent over hypotenuse, because you don't have a hypotenuse. You just have three sides of a triangle. So in doing that, that's how you're going to have to find at least one of your angles whenever you're only given three sides. Okay? With everything that we've done up until this point, you've always been given three values. Either two angles and a side, two sides and an angle, three sides, and now another two sides and an angle, but it's just a matter of what sides and what angles you're given. Okay? So you're at least going to have an angle, and then you go about it the way that you want. If once you get an angle, okay, remember, once you get two angles, you always have the third one, right? Because you can just subtract everything from 180 degrees. So at the bottom it says we only need to use law of cosines once. If you want to use it more than once, that's fine. I have no issue in that. Okay, it's a little bit longer of a process, but you can definitely shorten it up just as well. I'll have some students use law of sines because it's just cross multiplication, and they'll go about it that way. So whenever, does everybody have the adjusted formulas up there? Okay. So first case is when we have two sides and an angle, but the problem is we don't have a corresponding side to the 60-degree angle that we have. Okay? You have law of cosines. It's in the box on your reference sheet that you were given yesterday. If you want to put the other three like adjusted formulas on there, that's fine. Go for it. No issue in that. So you have a triangle. Side B is 20. Angle A is 60. Side C is 30. You don't have angle A. Or excuse me, you don't have side A. I need to find the third side first before I do anything else. So I need to find side A. So I'm going to have A squared equals B squared plus C squared minus 2BC times cosine of angle A. Now I just wrote out the formula, so then you have it. Now I just plug and chug where I have values. I don't know what A squared is. I'm going to have to take the square root at the end. I don't put everything underneath the square root because then it can get a little bit messy, so I'm just going to square root it at the end. So then if I have B squared, so I'm going to have 20 squared plus 30 squared minus 2 times 20 times 30 times cosine of 60 degrees. So now it's just a matter of doing the math. 400 plus 900 minus 2 times 20 times 30. So 1200 times cosine of 60 degrees. Now, this one should be fairly easy because what is cosine of 60 degrees? 1/2. So instead of 60 degrees, I can rewrite this as 1/2. So I'm going to do 1300 minus, not 6,000, 600. Remember, everything was equal to A squared was equal to now 700. Take the square root of both sides. So A is equal to square root of 700, 26.5. So, good question. Like with the 60 cosine of 60 degrees, like the only reason I could do that is like if it was 30 or like cosine of 30 degrees or something like that, then yeah, I would just plug it in because it would be a random number. So if A is 26.5, then it's just a matter of what you want to do to find the other two angles. Okay? So you can go back to law of sines if you would like. Okay? You could go back to law of sines, or you could use the modified equation of law of cosines. Okay? It's really up to you. I'll have some students that'll do one way. I'll have others that will do it whichever way that they want. The only thing, like where we've talked the past 2 days, or 3 days really, that you can't use a modified value, you have no choice here. Okay, you're going to have to use 26.5. Okay, I understand that it's rounded, but you have no choice in the matter. Okay, since you have that, then you're going to use 60. So if I go back to law of sines and go sine of 60 degrees divided by 26.5 equal to, if you want to find angle B first, you can, and divide it by 20. So if that's the route you want to go, then I'm going to take sine of 60 times 20 degrees, or not times 20 degrees, but times 20, and then divide by 26.5. So divide by that, do the inverse of that decimal, so second sine and then second to answer. I get an angle measurement of 41 degrees. So if that's 41, if it's 41 degrees down here, what is it up here with angle C? How much? 79. Okay. Then you have everything. Again, like I said, you could have done, you could have taken, since you now have those values, and if you were trying to find angle B, you could have done 20 squared minus 30 squared minus 26.5 squared divided by -2 times 30 times 26.5. Okay, that would have been just fine, and found cosine of B. Whatever value you would have gotten right with all of this, you would have done the same thing. Okay, you would have just taken 20 squared minus 30 squared minus 26.5 squared and then divided it by -2 times 30 times 26.5 and taken that same value in there. I would have still gotten 40.87. I still would have gotten the same thing. I still would have gotten 41 degrees for angle B. Okay, it's really up to you as far as what you want to do. If you want to go back to law of sines, go back to law of sines. If you want to still use law of cosines and use that modified equation or modified formula, do that. Okay, the second step, it's really up to you. The first step, you really have no choice. You have to use law of cosines. But your second step, it's on you as far as what you want to do. So then the second one, again, this is one where we have no angle, so you're going to have to use the modified formula. Okay, you're going to have to use the b squared minus a squared minus c squared divided by -2 times a times c. Okay. On problems like this, I would say that more students are apt, if they have just the three sides, they're more apt to use all modified law of cosine formulas than they are going to law of sines on the second step. And I'll show you why. So it's the thing that I would do first is I would always try to find the bigger of the three angles. So the bigger of the three angles is going to be B, right? So then if we go with the modified value, it's going to be b squared minus a squared minus c squared, all divided by -2 ac, and that's equal to cosine of angle B. So the reason why I always start with the bigger number is because then I don't have to worry about any sort of negative. Okay? because since it's bigger, it should work out to where there's not a negative on top, and things just work out usually a little bit easier. It's not guaranteed that you're not going to have a negative, but there's a lot better chance of you not having a negative on top. So then if I have 9 squared minus 6 squared minus 4 squared divided by negative 2 times 6 times 4, so 81 minus 64, or excuse me, 36 minus 16 all over a negative 48. So 81 minus 36 minus 16. So I have 29 over negative 48 is equal to cosine of B. Now, here's why students, whenever they have all the sides, here's why they usually like to use this instead. Because for like their finished product, or whenever they have to type it into the calculator, all they have to do is go inverse cosine, and they just have to type in negative 29 over 48 and just type in the fraction. So whenever they go inverse cosine, they have negative 29 divided by 48. They're going to get an answer of B is 127 degrees. 127.1688, all that jazz. So then if they get 127 down here, some students would rather deal with the fraction than having to like remember that they've got to go second in the answer, or they don't want to retype everything in. Again, you can go back to law of sines. It's really okay if you do. If you go back to law of sines and you use the 9 and the 127, and then you just pick the other angle or the other side, you're still going to get the same answer. Okay? If you would go sine of 127 degrees divided by 9 equal to sine of A divided by 6, you would multiply, you would divide. So you would have sine of 127 degrees times 6. You would then divide by 9. You would go second sine and second answer and have what? I have 32 degrees. So then I have 32 degrees, I have 127 degrees, I subtract that from 180, and I end up with a 21 degree angle up here. And you can do the same thing, like I said, if you are finding A, then all you would do is you would just have 6 squared minus 9 squared minus 4 squared divided by negative 2 times 9 times 4. And you would just do inverse cosine of, 36 minus 81 minus 16. And have negative 61 over negative 2 times 9 times 4, so negative 72. Some students would rather just go negative cosine or inverse cosine of 61 divided by 72. And you know what? They still get 32 degrees. Okay. It doesn't matter to me if you use law of sines on that second step or if you go back to law of cosines. Okay. For that second step, it's really up to you. The first step, you have no choice. Second step, you're driving the bus. Okay? Last one then is with Huron's formula as far as another way to find the area of a triangle. We talked yesterday about whenever you have the area, you can find the area of a triangle if you have one of the angles. Whereas here, if you, and I think you probably would have had this in a geometry class. I feel like you should have. But you can always find the area of a triangle by adding all the sides up and dividing by 2 or multiplying by a half. You can add Huron's formula to your reference sheet because it's not on there. I would just probably put it above like law of sines and above that box where there's a little bit of room, or maybe above the sum to product box where there's room there. So you want to add up everything. So if we find the perimeter, so like on the example here of number 4, if we find the perimeter first, we're going to have 12 plus 16 plus 24. So I get a perimeter of 52. That means the S value is half of that. So S is 26. So then again, it just becomes plugging it into my formula here of, I'm going to take the square root. I'm going to have 26 times 26 minus 12 times 26 minus 16 times 26 minus 24. So 26 times 14 times 10 times 2 is 7,280. So the square root of 7,280 is just 85. It's around to the nearest square yard, so 85 square yards.